All right, let's jump into another deep dive. Today we're tackling something pretty cool, energy communities and blockchain. Sounds futuristic, right?
It is, actually.
We've got this academic presentation about a research project, and they're using blockchain to, well, simulate these energy systems of the future.
Yeah, they're basically trying to figure out.
It's a lot to unpack.
Yeah.
How do we use computer simulations and blockchain to make energy trading more efficient, more secure, all that good stuff?
Yeah, so it all comes down to neighbors trading energy.
Oh, okay.
Literally trading energy with each other, creating like these mini power grids within their communities.
So like I've got solar panels, you don't, I can sell you some of my power.
Exactly.
Okay.
And the researchers in this project, they focused on a model with 4 houses.
4 houses.
2 of them have solar panels and batteries.
Okay.
They're called prosumers.
Prosumers, got it.
Because they both produce and consume energy.
Ah, okay.
And then the other 2 houses, those are just regular energy consumers.
All right, I'm with you. So it's kind of like this little neighborhood experiment, see how we can share energy.
Right.
But why? Yeah. Why blockchain? Why do we need to bring blockchain into this? It seems, I don't know, a little complicated for like a little community.
Well, just imagine trying to keep track of all those energy transactions between neighbors.
Yeah, I can see how that gets messy.
Right. It's a lot. But blockchain actually solves a lot of problems here.
Okay.
So first of all, it's super secure. Every transaction, so every little bit of energy that's bought and sold, it's all recorded on this tamper-proof digital ledger.
Ledger.
It's like a permanent public record.
Oh,
Everyone can see it, so no one can cheat, no disputes.
So it's like the ultimate neighborhood watch for energy. Okay, that makes sense. I get that. But what's the real advantage? I mean, does it really matter if my neighbor knows how much solar power I'm sending them?
Well, transparency is important, but the real game changer here is real-time optimization.
Ooh, optimization. I like the sound of that.
So with blockchain, energy can be traded almost instantly.
Wow.
So as soon as someone's solar panels make some extra power, boom, the system can automatically find a buyer, and the transaction, it just happens seamlessly.
No middleman, no waiting.
No, it's all automated.
That's pretty slick.
Right. And this dynamic energy flow that allows the community to respond to like any changes in supply and demand instantly.
So it makes the whole system more efficient.
Yeah, much more efficient.
Okay, blockchain is sounding pretty good right about now, but I do have one question. What about those transaction fees, those gas fees?
Yeah.
The ones we hear so much about with blockchain. I mean, didn't those almost kill off some of those early crypto projects?
Yeah.
I can't imagine that's good for a local energy market, right?
You're absolutely right. Gas fees are a huge concern when you're talking about lots of these small transactions, like you would have in a neighborhood energy community.
Right.
And the researchers, they knew that this could be a deal breaker. So they came up with some pretty ingenious solutions.
All right, you've got to tell me, did they actually find a way to make this blockchain thing work without costing an arm and a leg?
They did. Their secret weapon. 2 things.
Okay.
Batch processing and predictive analytics.
Okay, break those down for me.
All right, so batch processing, think of it like carpooling for energy transactions.
Oh, okay.
Right. So instead of each person driving their car to work, everyone in the neighborhood piles into a few buses.
So you're sharing the cost, makes it much more efficient.
Exactly.
Okay.
So they're basically bundling all these little energy transactions together into bigger batches.
Okay.
To cut down on those overall transaction fees.
All right, that's pretty clever.
But it gets even smarter.
Oh, there's more?
They also use something called predictive analytics.
Oh.
So by analyzing data on how gas fees fluctuate,
Okay.
they can actually pinpoint those times when the fees are the lowest, and then they schedule those big transaction batches to happen during those low fee periods.
So it's like checking the traffic report before you leave the house and planning your route to avoid rush hour.
Exactly.
Okay, that's impressive.
Right.
Some serious cost-cutting strategies going on there. It sounds like they've really thought this through.
They have. And they didn't stop there. You've got fluctuating energy demands, making sure there's enough energy to go around, figuring out how to rely less on the main power grid. I mean, these are all complex challenges they had to tackle.
And I bet that's where their fancy simulation software comes in, Simulink, right?
Exactly.
From what I understand, this isn't just some regular computer program, is it?
No, it's not. Simulink, it's a really powerful tool for modeling complex systems.
Okay.
It lets you create a virtual version of something and see how it behaves under different conditions.
Oh, okay.
So in this case, what they did is they built like a digital twin of their energy community inside of Simulink.
Oh, cool.
Right. Complete
Yeah.
with the houses, the solar panels, batteries, all the energy trading going on.
Wow.
They can then run all kinds of scenarios. Like, what happens if the sun isn't shining or energy demand suddenly spikes? And they see how the system responds in real time.
So it's like a high-tech dress rehearsal for a real-world energy community.
Yeah, that's a great way to put it.
Okay, so I think I'm starting to see how all the pieces fit together here. You've got this community model, you've got blockchain for the secure transactions, and then you've got Simulink to create like a playground for testing everything.
Exactly. It's this combination that makes this research so powerful.
Okay.
Simulink lets them experiment and see how different factors impact the system, while blockchain provides that secure foundation for tracking and managing all those energy trades.
Okay, so they work in perfect harmony.
They do.
I like it. So let's talk about those simulations. They put their system through two main tests, right? The first one was like a normal day scenario.
Yeah, just seeing how well the community could meet its energy needs using local resources. Basically, how much could they rely on solar power and battery storage to minimize what they had to buy from the main grid?
Okay, so maximizing that neighbor-to-neighbor energy exchange.
Exactly. Make the community as self-sufficient as possible.
I like it. I like it. But then they threw a wrench into the works with the second test, didn't they?
They did. For the second scenario, they simulated what would happen if there was no solar energy available at all.
Oh, wow.
Thinking like a really cloudy day,
Okay.
or even a temporary outage on the main grid.
Okay.
They wanted to see how resilient the community was when it was forced to rely solely on their batteries and whatever they could get from the grid.
That's a pretty intense stress test. It's like throwing a curveball and seeing if it can still hit a home run. Okay, I'm on the edge of my seat. What happened next?
Well, before we get to the results, let's take a closer look at how energy flows within this community on a typical day. Imagine you're a resident in this microgrid neighborhood.
Hold on, hold on. Before we get into the day in the life stuff, I really want to hear about those tests. You're telling me they simulated a whole day in this energy community? That's got to be fascinating. Let's save that story for later and jump right into those results. Did this thing actually work? Come on, don't leave me hanging. How would that system handle those tests? Did it work or did it totally fall apart?
Oh, it's pretty exciting, actually. They tested it all out on the Sepolia Ethereum test network.
That's like a practice arena for blockchain projects, right?
Exactly. And they found that their whole batch processing and predictive analytics combo worked like a charm. They really knocked those transaction fees down.
Ooh, that's good.
Which is a big deal if we're talking about actually using blockchain for energy trading in the real world.
Okay, so they proved it could be affordable, even for like just sharing energy between neighbors.
Right.
That's a pretty big deal. But did they just test one way of doing those batches, or did they try a bunch of different things?
You know, that's one of the things I really like about this research.
Yeah.
They were super thorough. They tried batching transactions over like 1 hour, 2 hours, 3 hours.
Okay.
To see, what that sweet spot was.
Yeah.
Where they could get the lowest fees, but still keep things moving quickly.
So like fine-tuning the engine for the best performance.
Exactly.
Okay, I can picture them now, all huddled around their computers, running those simulations and tweaking everything till it works. But let's zoom out a bit. We've got this system that's secure, transparent, and thanks to their clever tricks, it's affordable too. But so what? What's the big takeaway here? Why should we care about all this energy trading and blockchain stuff?
Well, I think it could actually change how we think about energy.
Okay.
Imagine neighborhoods that aren't just using energy from the grid.
Yeah.
They're producing and sharing it themselves. Like little microgrid ecosystems that are way more resilient, efficient, and sustainable.
Oh, okay.
This research is showing us that that future might not be so far off.
So we're on the verge of like an energy renaissance, moving away from those huge power plants and towards something more local, more community driven.
Exactly.
It's an exciting idea. But I do have to ask, we keep talking about this day in the life of an energy community.
Right.
How would this actually work? Like, take me through it.
All right, so picture this. You wake up on a sunny morning in your microgrid neighborhood.
Great.
The houses with those solar panels are already buzzing, turning that sunlight into electricity.
Huh?
And as the energy starts flowing, the whole system automatically figures out who needs what.
Okay.
And it starts the trading between the houses. Some
Yeah.
homes are using the energy right away. Others are storing it in their batteries for later. And all this is just happening in the background. No one even has to think about it because of blockchain and that real-time optimization.
So the neighborhood is just humming along, powered by its own clean energy. Sounds pretty idyllic. But what happens when the sun starts to go down and those solar panels aren't making as much power anymore?
Well, that's when those batteries kick in.
Huh.
Remember, all those houses that had extra energy earlier were storing it up.
Right, right.
So as the sun sets, the stored energy starts flowing back into the grid, keeps everything running.
Like a backup generator built right into the community.
Exactly.
Very cool. But what about nighttime when the sun is completely down? Do we just have to go back to relying on the main grid then?
Yeah, that's a possibility. I mean, the goal is to use the grid as little as possible.
Right.
But there might be times when you need it, especially if those batteries are running low.
Okay.
But even when the community is using energy from the grid, the whole system is still working behind the scenes, making sure things are as efficient as possible.
It's a constant balancing act, adapting all day long. This whole thing sounds super complex.
It is, but that's where the simulation comes in. Simulink lets them model all this complicated stuff, test out different strategies,
Yeah.
you know, tweak all the variables, run all these scenarios, and they get these really valuable insights into how to actually make it work in the real world.
Speaking of insights, the researchers mentioned they were going to work on something even more futuristic next. Something about AI-powered transaction scheduling. What's that all about?
Now, that's where things get really wild. So right now, the system is using predictive analytics to schedule those transactions based on past data about gas fees.
Oh.
But imagine if it could actually learn and adapt as it goes.
Oh.
Using AI to predict how much energy people are going to use and automatically adjust how the trading works to get the best efficiency and the lowest costs.
So we're talking about a truly intelligent energy grid, one that's always evolving, always getting smarter. I mean, this could completely change how we interact with energy, give us more control, more flexibility, and maybe even a stronger sense of community.
Exactly. It's about making energy more democratic, giving people more ownership and control over it.
We've covered a lot of ground here, from the nitty-gritty details of batch processing and predictive analytics to this, grand vision of a future powered by intelligent microgrids.
Yeah, it's been quite a deep dive.
It has. But before we get too carried away with all the possibilities, let's take a step back and recap what we've learned.
Okay.
What are the key takeaways here?
I think the big thing is this research is really showing that we can use blockchain to build these secure, transparent, and affordable energy trading systems within communities.
Okay.
They've actually shown how to overcome those blockchain challenges, like the gas fees, and use its unique features to optimize how energy flows and create a more resilient and sustainable energy system overall.
It's a great example of how we can use new technology to solve real problems and create a better future, you know?
Absolutely.
But I can't help but wonder, what if we could take this beyond just neighborhoods? Could we scale this up to entire cities or even whole regions?
I mean, that's the big question, isn't it?
Yeah.
This research, it's really just the beginning, It's showing us what might be possible, but there's still so much we don't know.
Right.
But imagine cities powered by all these interconnected microgrids, all managed by smart systems and blockchain.
Yeah.
It would be so different from how we do things now.
Yeah.
And it could completely change how we get our energy.
It's like we're talking about a whole new way of thinking about energy, right?
It is.
Instead of just, getting it from the power company, it becomes something we're actively part of, something we have control over.
Yeah, exactly. It's about making energy more democratic, giving people and communities more ownership, more say in how it works. And it's not just about the technology. It's about changing how we think about energy, working together, sharing the responsibility to make things more sustainable.
I love that. A more collaborative, more sustainable energy future. That's really inspiring. But we've got to be realistic too. I mean, there are going to be challenges, right? This isn't going to be easy.
Oh, absolutely. Making this kind of big change won't be simple. There are technical things to figure out, rules and regulations to deal with. And probably the biggest thing is people need to understand it.
Right.
They need to trust these new systems.
It's not enough to just invent new technology, right?
Yeah.
We have to build systems that people actually get and trust and want to use.
Exactly. And that's why research, open discussions, and getting communities involved are so important. We have to talk about the good and the bad, address people's concerns, and work together to build a future that works for everyone.
That's a great point. Well, I think it's time to wrap up our deep dive for today.
Yeah.
We've gone pretty deep into these energy communities and blockchain technology, and I gotta say, I'm feeling really optimistic. What about you?
Yeah, absolutely. This research really shows that a more sustainable, more resilient, more equitable energy future is possible. It's within reach.
It's a future where we're not just using energy, we're shaping it. We're part of creating a system that gives people more control, strengthens communities, and protects the planet.
Couldn't have said it better myself.
Well, thanks for joining us on this deep dive into the future of energy. Until next time, keep exploring, keep learning, and keep those questions coming.